So in this part of the video, I will give you some examples. So in this section, when we do the questions, we have some steps to follow. So please mark down the steps on your notebook. So there are 4 steps. First, we have to construct a triangle in the coordinate plane, and then we have to write down and calculate all the lengths. Afterwards, please define H, O, and A. And finally, we can calculate sine theta, cosine theta, and tangent theta. So now I will talk about examples 10.1 in your textbook, page 10.12. So in this question, it asks you to find sine theta, cosine theta, and tangent theta. So in part A, as you can see, the length OA is in quadrant 2. So therefore, we will add a line like this, okay, to form a triangle in quadrant 2. And it is a right angle triangle. Then look at the coordinates of P. The -3 refer to the x coordinate. So I will mark it down as -3. So similarly, for the y coordinate 4, it is talking about the length in the y-axis. So I will mark it down as 4. So therefore, we have to calculate the length of OP. So part A, the square of OP, it is equals to -3 square plus the square of 4. And we are applying the Pythagoras theorem. Then the square of OP is equal to 25. Then we have to take the square root. But don't forget that when we take the square root, we have to add a plus or minus in front of it. And finally, we have 2 values. The first one is +5, and the second one is -5. So please be reminded that for the hypotenuse, okay, that means OP, it must be positive in value. So therefore, the -5 has to be rejected. Okay, so therefore we know that the length of OP is 5. And then I will draw the triangle again. So we know that for the horizontal distance, it is -3, and for the vertical distance, it is 4, and for the hypotenuse, it is 5. Okay, and then I mark down the angle. So finally, for the third step, we have to define H, O, and A. So for the longest side, that is 5. So I know that it must be H. And then for the angle, the opposite side will be 4. So I mark it down as O. And finally, the -3 will refer to A. Okay, so finally, we can calculate sine, cosine, and tangent using the 3 lengths of this triangle. So for sine theta, it is O over H. So it is 4/5. Okay, then for cosine theta, it is A over H. So that it is -3/5. And finally, for tangent theta, it is equals to O over A. That is 4 over -3. Okay, this is the end of part A. Okay, so let's move to part B. Okay, so as you can see now, OP is in quadrant 4. So according to our notes, the triangle should be constructed in this way. Okay, so that we have the right angle triangle. Okay, then again, for this 3, it is talking about the length in the x-axis. So it is 3, and for the -2, it is talking about the y value. So -2. So finally, we have to calculate OP. Once again, we are using the Pythagoras theorem. The square of OP, it is equals to the square of 3 plus the square of -2. Okay, so afterwards, we know that the square of OP is equals to 13. Once again, when we're taking the square roots, we have to write a plus or minus in front of the square roots. And finally, there are two values for OP. One is positive square root of 13 or negative the square root of 13. So as you can see, we are calculating OP, that means the hypotenuse. So therefore, the negative value has to reject. Okay? And the next step, after we calculate all the three lengths in this right angle triangle, okay, OP, and then I just write down all the length back into this right angle triangle, and then define the angles that we have to discuss. So let's move to the third step, that is define HONA. Again, hypotenuse is OP, and then -2 will be representing the opposite side, and finally 3 is representing the adjacent side. So let's come to the fourth step, that is calculating sine theta, cosine theta, and tangent theta. So for sine theta, it is O over H, so it is -2 over the square root of 13. And for cosine theta, it is A over H, so it is 3 over the square root of 13. And finally, for the tangent theta, it is O over A, that is -2 over 3. So this is the end of part B. So let's compare the two results in part A and part 2. So as you can see, in part A, the triangle is constructed in quadrant 2. So using the result of ASTC, we know that in quadrant 2, only sine theta is positive. So as you can see, sine is positive, and for cosine and tangent are negative. So that means all the answers are reasonable. So similarly, for part B, we know that the triangle in quadrant 4, only cosine theta is positive, and for sine and cosine, sine and tangent are negative. So again, all the values and all the answers in this part are reasonable again. So now please help me to do the correct practice. 10.1, okay, and check the answer for yourself. You can pause the video and do the correct practice. So now I will talk about examples 10.2 in your textbook, page 10.16. So in this question, it is given that sine theta is 24 over 25, where theta is between 90 degree to 180 degree. And the question asks you to find the values of cosine theta and tangent theta. So there are two important information that is given in the questions. So please use a red pen to mark it down. So the first information is sine theta is 24 over 25. So we know that for sine theta, it is O over H. Okay, then next, the range is given. Okay, 90 degree to 180 degree. So we know that the triangle is in quadrant 2. Okay, so our first step is let's construct the diagram together. Okay, we have the XY axis. Okay, as we know that the triangle is in quadrant 2, so therefore, okay, the triangle will be constructed in this way. Okay, and we know that there is a right angle here. Okay, so again, we can construct a P as the point with the coordinate x and y. Okay, so then we know that sine theta it is equals to 24 over 25. So h is equals to 25. And then for the 24, it is the opposite sign. Okay, so then we let P xy be the point. Okay, so next we have to find all the values in this triangle, and as you can see, the x is an unknown. So therefore, we have to apply the Pythagoras theorem. So the square of 25, it is equals to the square of x plus the square of 24. So finally, we know that the square of x is equals to 49. Okay, so again, when we are taking the square root, we have to write plus or minus in the front. Okay, after calculating, we know that x is equals to positive 7 or negative 7. Okay, so please be careful. This time, as the x value is in the negative direction, okay, so therefore this time is not the negative 7 being rejected. Instead, we are rejecting the positive 7. So, in the figures, I will mark down x is equals to negative 7. So now, we have all the three lengths in the right angle triangle. Then we can draw it again. Okay, with negative 7, 24, and 25. Okay, and then mark the angle that we are discussing. So again, after finding the three lengths, we have to define h, o, and a. So it is obvious that 25 is the h, 24 is the o, and negative 7 is the a. And finally, please answer the question. For the cosine theta, it is a over h, that is negative 7 over 25, while for the tangent theta, it is 24 over negative 7, o over a. And this is the answer. So again, let's check the answer if they are correct or not, or if they are reasonable or not. So for quadrant 2, cosine and tangent are negative. Okay, so our results are negative. So it is they are making sense. Okay, so now please help me to do the correct practice. 10.2. Okay, you can pause the video and then do the correct practice. Okay, and then finally for today's homework, it is exercise 10a, question 5 to 8, 13, 15, and 29.